Hello student, in this video we are going to learn the different relations between EMF and the thermodynamic properties like enthalpy, entropy and free energy. Now let us see the first, that is the free energy change and EMF of a electrical energy. In reversible electrochemical cell, if a infinitesimal amount of a current, infinitesimal amount of a current means small amount of current is drawn from the cell. If you draw certain current from the cell, then the maximum work done is equal to product of potential difference and the charge flowing. That work done during that process of drawing certain current from a reversible cell, that maximum work done is given by means of a product, that is the product between potential difference into charge flowing. W max is the maximum work done during that process. What is the process? The process is that you have to withdraw certain current from that cell, and therefore W max is equal to E, which is a potential difference of the EMF, into charge flowing. Charge flowing is N into F. Therefore, W max is equal to N F E, where E is the EMF, N is the number of electrons liberated at an electrode, and F is the Faraday. Now, according to the Gibbs and Helmholtz, who pointed out that the electrical energy is produced at the cost of free energy, that is delta G. What says the Gibbs and Helmholtz? Gibbs and Helmholtz says that the electrical energy is produced at the cost of the free energy, that is change in free energy, delta G. Thus, the decrease in the free energy is equal to the work done. The meaning of this term is that due to use of free energy, there is a maximum work done according to the Gibbs and Helmholtz. Gibbs and Helmholtzच्या म्हणण्यानुसार जे इलेक्ट्रिक करंट जनरेट व्हायला होत आहे त्या इलेक्ट्रोकेमिकल सेलमध्ये, इट इज ड्यू टू द कॉस्ट ऑफ the free energy. That means free energy is utilized, and when free energy is utilized, then change in the free energy will be negative, and therefore the delta max, W max is equal to minus delta Z, or we can write here the minus delta Z is equal to NFE, where NFE is equal to W max. W max is equal to काय NFE आहे, म्हणून W max च्या जागी काय ठेवलं की आपण NFE लिहिलं आहे. Or if you rearrange it, delta G is equal to minus NFE. Now this is the equation which gives the relation between free energy change and EMF of the cell. The negative sign indicates that there is a decrease in the free energy. Free energy काय झाली इथं decrease in the, there is a decrease in free energy. This equation gives the relation between free energy change and EMF of the cell. Now here is the certain possibilities. If delta G, that is change in free energy, is less than 0, that means negative, the cell reaction is spontaneous. Cell reaction is spontaneous. That means it occurs at its own accord without any other source. E cell will be the positive at that time. EMF of the cell is the positive. The cell acts as a source of electrical energy. At that time, that cell will act as a source of electrical energy. It will act as a galvanic cell. It is acts as a voltaic cell. That means there is a generation of electricity when delta G is negative or less than 0, right? Now then, second possibility is delta G is greater than 0. That means it will be the positive. The cell reaction is a non-spontaneous. It will not occur at its own accord. स्वतःहून घडून येत नाही, त्याला बाहेरून सोर्स दिल्यामुळे ती रिॲक्शन घडते. That E cell will be the negative. cell will not operate. That means it is not acting as a galvanic cell or the voltaic cell. It may act as a electrolytic cell or the voltmeter, right? The cell will not operate spontaneously. Now this is the second possibility. Third possibility, delta G is equal to 0. That means the EMF of cell is 0. This state is called as the equilibrium state of the cell. It is called as the equilibrium state of the cell. Now this is the first relation, that is the relation between delta Z and the EMF of the cell. Now let us see the another relation, that is the relation between enthalpy change. Enthalpy change means the heat change. It is given by delta H and the EMF of the cell. Now according to the Gibbs and Helmholtz equation, आपल्याला माहिती आहे आपण डिराइव केलेला आहे Gibbs and Helmholtz equation, which apply to the reversible change, that is the reaction occurring in that cell. Delta G is equal to delta H plus T d delta G by dt, किंवा याला म्हणता येते delta G is equal to delta H plus T into bracket dou delta G by dou T at constant pressure. Now this is the Gibbs and Helmholtz equation, where delta H is the enthalpy change, delta G is the free energy change, and T is the absolute temperature. Now as we derived this equation, that is delta G is equal to minus NFE. आपण आताच हे इक्वेशन डिराइव केलं. काय आहे? delta G is equal to minus NFE. Now put the value of this delta G in this equation. Here instead of delta G minus NFE. Here instead of delta G minus NFE. Now rearrange it minus NFE as it is delta H plus here. Now take this minus n and f outside the bracket, च्या बाहेर काढा मायनस ला आणि n f ला. Therefore minus nft, ब्रॅकेट मध्ये काय राहिलं? dou E by dou T at constant pressure. Now we rearrange it for delta H because we have to derive the relation between enthalpy change and EMF of the cell. Therefore delta H is equal to, transfer this on right side and multiply throughout by means of a negative sign, we will get this equation. हे जे इक्वेशन आहे याला रिअरेंज जर केलं आपण, डेल्टा जी इकडे आणलं तर मायनस होईल, हे जर इकडे नेलं तर प्लस होईल, आणि याला थ्रूआउट जर मायनसनं मल्टिप्लाय केलं तर वी विल गेट डेल्टा एच इज इक्वल टू minus NFE plus NFT dou E by dou T at constant pressure. Now this is the equation which gives the relation between the enthalpy change for a cell reaction if and that of the EMF आणि enthalpy change मधलं रिलेशन देतात. जर तुम्हाला enthalpy change काढायचं असेल सेल रिएक्शन मधला तर इट कॅन बी डिटरमाइंड बाय यूजिंग द EMF ऑफ द सेल. सेलचं EMF जर माहिती असेल तर आपण काढू शकता. नाउ दिस इज अ टर्म which is called as a temperature coefficient of the EMF. That means if you know the temperature coefficient of EMF for the cell, then you can calculate the enthalpy change. E आणि temperature coefficient of temperature ह्या दोन गोष्टी जर माहिती असेल तर हे काढता येईल. Because T is the temperature at which the cell is operating, F is the Faraday, N is the number of electrons which get exchanged during the process. Now in this way it gives the relation between enthalpy change and that of the EMF. Now then another relation, that is the relation between enthalpy change, entropy change, not enthalpy change, and that of the EMF of the cell. Now according to thermodynamics, the relation between G, H and S are given by means of this equation, that is G is equal to H minus Ts. Now this is the definition of the free energy, where G is the Gibbs free energy, H is the S is the entropy, H is the enthalpy, and T is the absolute temperature. ठीक है, absolute temperature. All these are the thermodynamic terms. Now for a given change at constant temperature, the equation becomes the change in free energy and change in enthalpy change. Enthalpy change is given by means of delta Z is equal to delta H minus T delta S. कॉन्स्टंट टेम्परेचरला आपल्याला याच्यातलं रिलेशन सांगता येतं, डेल्टा जी इज इक्वल टू डेल्टा एच मायनस टी डेल्टा एस. हे सुद्धा इक्वेशन आपण डिराइव केलेला आहे. Right, rearrange it. Delta z, shift this term on the left side, therefore it becomes minus delta h is equal to minus t delta s. This is the equation number 1. Equation 1 आहे. या equation मध्ये delta z minus delta h is equal to minus t delta s आला. Now according to the again Gibbs and Helmholtz equation, delta z is equal to delta h plus t into bracket dou delta g by dou t at constant pressure. हे आहे Gibbs and Helmholtz equation. याला rearrange करा. Now this delta h is shifted on the left side, therefore delta z minus delta h is equal to t into bracket dou delta z by dou t at constant pressure, equation number 2. Now from equation 1 and 2, compare the equation 1 and 2. Now this left hand side of both equations are same, therefore we can say that the right hand side of equation 1 and right hand side of equation 2 will be the same, and therefore we can write minus t delta s is equal to t into bracket dou delta z by dou t at constant pressure. Therefore delta s is equal to minus dou delta z by dou t at constant pressure. But we know that delta z is equal to minus nfe. Delta z is equal to minus nfe. Therefore delta s is equal to minus, put the value of delta z, it is minus nfe by dou t at constant pressure. आपल्याला माहिती आहे की डेल्टा z इज इक्वल टू काय आहे, मायनस एन एफ ई आहे. मग ही जी मायनस डेल्टा जी ची किंमत आहे ह्या इक्वेशनमध्ये इथं ठेवलेली आहे. राईट, हे मायनस बाहेर काढलं, मायनस मायनस प्लस होईल, एन एफ बाहेर काढा, एन एफ बाहेर काढला तर इथं राहतं काय, डेल्टा एस इज इक्वल टू एन एफ dou E by dou T at constant pressure. Now this is the term which is called as a coefficient of EMF of coefficient, temperature coefficient of the EMF. आपण आताच पाहिलं की ही जी टर्म याला काय म्हणलेलं आहे, temperature coefficient of EMF and delta S. Thus this is the equation which gives relation between entropy and the EMF of the cell. In this way we derive the relation between three different terms, that is the EMF and free energy change, second EMF and the enthalpy change, and third EMF and the entropy change. Now we will stop here. Thank you.